All right, so welcome to the first in our lecture series here for student game developers. I'm glad that many of you made it out, but we are also going to be filming this, so the three lovely people who are in the way, right? Not in the way, but slightly back of the heads, you're going to be famous by the time this is over. Or at least the small amount of back of the head is going to be famous. If that frustrates you in any way, you can move. But I'd be famous, or I'd be happy if like a small eighth of the back of my head was on YouTube. That's just me. Thomas, could you just periodically check that it's still recording? Because it likes to auto not record. It's an interesting function for a camera to have. Just auto not record. Is this going to be working?
What's the record button if it turns off?
The red button.
See, we at SGD like to pair beforehand.
We're software people. Anyway, so this is our first lecture series. Jack, our fabulous director of Game of Swords. Many of you know him as your director because many of you are on his project because Jack's project is the largest in student game developers history in all 7 years.
25 people.
25 people and potentially growing if he wants to add more. Anyway, so in addition to having all that work with Game of Swords, Jack has offered his expertise in using Git, which is a form of version control. Now, version control is incredibly important for game development because there are multiple people working on a specific project, or in Jack's case, 25 plus. Now, if 25 plus are trying to all add something to a Dropbox and continually re-download the Dropbox every single time, it's not going to work out well. So we use version controls like SVN, but Jack is going to teach you Git today. Just a note about the lecture series before I head off. If doing something like this, like teaching about Git or teaching about art, music, writing, if you have an idea for kind of a lecture that you'd like to do, please send us an email because we're incredibly open. Next week, for many of you put down that you'd like to learn basic programming. Maybe not people in this room, but just learning basic programming. I'm going to be doing that lecture next week. We're going to learn how to make 3 basic games in Java and just how game design and programming, like very basic programming, goes hand in hand. If that interests you, I sent out an email today, and you can log in and put on the Doodle poll what times you'd like. But if you're already in CS 11.10 or are past that, it's probably not going to be for you. But if you'd like it for review at CS 11.10 or below, then it might be very helpful. Anyway, I'm done talking. Jack's going to take the lead, and you guys are going to learn about Git. Okay?
All right, thank you, Nick.
Okay, before we start, just to clarify, if you've got an idea for a tutorial you'd like to lead, or if you just have an idea for a tutorial you want to see, come talk to us. Because even if you yourself couldn't make this happen, we probably know someone who can. So if you've got an idea of something you'd want to learn about, something you think that would be remotely related to game development, we're interested. All right, that being said, let's commence with the first in our tutorial series titled Get Going, How to Use Version Control Now to Spare Yourself a Nightmare Later. All right. So before I begin, a little bit about myself. I'm a third-year CS student. I've worked several projects with Git and Subversion, about 50-50 at this point. So I've got some experience with both of them. However, I'm by no means an expert. So if you see something here that's blatantly incorrect, I might be wrong. That being said, I will do my best to inform you all and give a basic working knowledge of Git. The talk borrows extensively from a book called Pro Git, which is available online under the Creative Commons Attribution License. And this talk borrows heavily from that. So, a quick overview. What I plan on going over are the fundamentals of version control in an abstract way, and then looking closer into how Git operates, an explanation of common Git commands, and then looking a little bit in how to use Git to create a better workflow than if you're not version controlling at all, because in addition to synchronizing code, it can help out in a lot of ways with making your workflow a little more sensible, so you have less of those banging heads on keyboard moments. What I will not be spending a whole lot of time on for this talk are the discussions on the specific implementations of Git. There are a lot of them, command line interfaces, GUIs, plugins for various IDEs. Which one you use depends on the project. For example, my team will be using the Eclipse plugin for Git, whereas other people won't be able to do that. We'll have to use the GUI or the CLI. However, the different implementations, they all use the same commands. They're the same words, essentially. So if you understand Git in an abstract sense, it's very easy to port that knowledge to different implementations. So with that, let's commence. So the problem that we face is what happens when you want to code a project with more than one person, which is a nice thing to do because if you have more than one person, you can do more things, obviously. However, more than one person likely means more than one computer. More than one computer means more than one set of code. And synchronizing that code is the trick. So the CS1110 version of resolving this conflict, if you guys remember, at least this is the way it happened when I was in that lab, was you email the files together and then one intrepid member of your group would copy-paste them together. I don't know if any of you have tried to do this, but it is awful. It's a nightmare, and it leads to you taking a long time, and then some method doesn't get put in properly, your code breaks, and you lose points on what should have been a hole-in-one A. So we then move on to the CS2110 version of this, at least when I took it. It was repositories are scary, let's use Dropbox, which admittedly a lot better than email. However, you'll still have to do a little bit of copy pasta to merge files together. All Dropbox does is synchronize the individual files themselves. So, real solution to this problem, version control systems, or VCS, solves the synchronization problem in a much better way than email or Dropbox does. It's set up to organize changes to files, to a directory, so not just code files, but any files within your project space. It organizes the changes in one place and will synchronize it among multiple users. So basically, you can modify files, coders write code, artists add art, musicians add music, and then you add that change to a repository, which is just a set of states that the directory was in, version 1, version 2. And then other users can see that change instantly. So this means that everyone can work on the directory independent of each other. You don't need to coordinate times to work on the code, because otherwise your copy-paste won't work. Work on it independently because it's very easy to merge the states in the repository together. So it allows you to spend more time focusing on getting your part of the code working and less time worrying about how the code will integrate together. There are many different implementations of version control. It's an abstract idea. Most of them will fall under two tents, central version control and distributed. We'll start with central, as this has been the classic version control method. Subversion, CVS, Perforce are all central version control. The way that works is your repository is on a server. The server has the list of every state that the directory was in at any time, and users will check out the latest copy, make their edit, add that copy back in. But all that's on the user's computer is the latest part of the directory. So to make a nice little graphic about it, there's the server in the cloud, and each user is getting updates from the server, then modifying their code, and then committing the code back up to the server. But it's just directly to their workspace. Distributed version control is a much more recent development. Examples are Git, which we'll be exploring more thoroughly in this lecture, Mercurial, and Bazaar. I have no idea how to pronounce that. So with distributed version control, unlike central, every user has a copy of the entire repository on their computer. So theoretically speaking, you don't need a server at all, since every computer is, in effect, the database, and you would just need to synchronize among the computers. That being said, most of the time you'll be using a server anyway, because that's a nice centralized location to sync all the code. So this creates, although it's very useful in the long run, it creates some sort of confusion because there's essentially two stages to to synchronize your changes instead of one with central. So the first part is on your computer only. This could be done with no internet access. Theoretically, you have your files, and then you have your repository. And you'll be writing your files, committing them to your repository, and then if you want to get something from your repository, you do a merge command, which will merge the files in the repository with your working files to create the update you're looking for. Part 2 deals with your repository and the server, although in this case the server could be either a central server like GitHub or any other user's computer. But this is where fetch takes the server's set of states and puts them on your repository. And push is the exact opposite. Takes the new states in your repository and moves them to the server. So in total, the flow of data looks like this. You have your individual users that are modifying their code. They then commit their code to their repository. And then when they're all ready to go, they can push that code up to the server, at which point other users can pull that down and work with the updated code. So there are advantages and disadvantages to each style. The big advantage of centralized systems is that there's less disk space on your hard drive because you only have one state, whereas in a distributed system, you have every state of the directory that ever was since the beginning of the project on your computer, and that can add up relatively quickly. However, distributed systems, the operations are a lot faster since there are only two operations that require any network at all, and that's the fetching and pushing, which is when your repository and the server are synchronized. You can commit to your own repository till the cows come home, and you won't have to deal with network at all, which can be very useful for committing often so that you have a sort of baseline to go back to if you screw up your code. Also, there's less failures, points of failure, or there are more points of failure technically, because every copy or every person on your team is effectively a backup of the database. As an essential system, unless you are backing up the server on which the code resides, that's the only copy. That's the only full history of the data. So if that goes away, then you're. All right, now we'll be looking a little closer at Git, which is probably the most common of the distributed version control system applications. It's the one that will be used by most SGD projects. I'm not aware of one that doesn't use it. However, there may be one. I know my project, for one, will be using it. And the reason I did this talk at first is that Git is a little weird to use at first. It ends up being a really nice way to work on your code, but the commands take some getting used to. So I'm here to hopefully shorten that learning curve a bit. So first we've got to look at how Git stores its data, because it'll become a lot easier to understand why Git does what it does when you know how it's doing it. So what Git will do is take an entire snapshot of your repository when you commit and store that in a commit. Technically lead to a lot of redundant data. As you see in commit 1, you put in files 1 and 2. And then the next time, file 1 is unchanged, and file 2 you made some modifications to, and then you add file 3. So what Git will do is it'll see file 1 is unchanged and just provide a simple link to the old file 1. But for file 2, no matter how minor that change is, it'll just take another copy of file 2 and put it there. And then it'll add file 3. And this works the whole way down. If you change a file, it'll add that file as a new copy in your commit, so that including following the links, you can, from one commit, get the entire directory ready to go. Okay, Git modifies this repository using various commands. These on the command line, you would do git space command, like git fetch, git clone, git add. GUIs will have buttons and menus for them. The most common ones, the ones that you'll be using likely even if you're not a programmer, in order to constantly have the latest copy of the code and to add your changes in, are fetch, merge, commit, and push. And I'll go over those in a second, but first I want to talk a little bit about setup. To set up a Git repository, first you need to either find a site to host your code. GitHub is a great choice because it's free. The only downside being that your code is public. Everybody has read access. You control who has write access to the repository, but anyone can look at your code. So if you want to keep your code secret, GitHub may not be the right choice. Or you may have to stump for a premium account. You can also host your own. I worked on a project where this trying to use wasn't working, and he had a server in his room, set that up with a repository. It's doable, but GitHub's a lot simpler. Then you'll give the URL to everyone on your project, and you'll add them as collaborators to the project. This is something that your directors will be doing. And then all users can clone the repository using git finding clone on GUI. And that'll download the entire repository on your computer. So then you have a repository and you're ready to go. All right, now, the big commands. First, we'll start with fetch and push. These are the commands, as I said earlier, that synchronize your local repository with the server. So if you do these commands, they leave the directory you're working on unchanged. This is just on the repository level. Fetch will take the code from where you're fetching, we'll say the server in this case, take all of the new commits in there and add them to your repository so that you can then get to work on them. That'll be likely the first command you do in a given session. Push is the opposite, takes the new commits in your repository and adds them to the server. This will be the last command you do once everything's ready to go to the server. Merge and commit is what happens on a local level. Merge will take the files and the commit you're trying to merge with. As I showed you earlier, they have a copy of every file ready to go. And then takes that and the files currently in your directory, squishes them together, and gets smart about it. And so in the vast majority of cases, it'll handle these mergers automatically and then leave your directory fully updated, ready to go. And you do your work, and then when you're ready to put your work back in the repository, you commit, which in this case is a verb, which will make a new commit, the noun, out of your files in your directory. We'll take them all, copy the ones that are changed and add links to the ones that are unchanged, take that as a new commit and put it in your repository. So to sort of review this part of it, a typical coding session would look a bit like this. You fetch the code from the repository first. It's now on your repository. It was taken from the server. Merge that commit that you're trying to update with into your work session. So then you write your code, add art, whatever you're set out to do. And then once you're done and it's ready to go, commit that code to your repository and then push it up to the server. So that's a typical coding session. And now we'll look into something a little more advanced, branching, which is where Git will really start to shine. So a branch is just a pointer to a commit. For those of you, it's just like a C++ pointer. It's a tiny file, and it just, as the commit itself has all the information you need to set up the directory from. Branches, unlike commits, are not synced in quite the same way. So the server will have its set of branches, and your repository will have its set of branches, and it's not quite automatic that the branches up with each other. That's something you have to do manually. So commits will help allow multiple developments in the same directory. So if user 1's working on foo.java, user 2's on bar.java, and they both rely on zaz.java, they can both work on their code and then on separate branches. And then when you go to later merge those branches together, it'll add foo and bar, and then it'll set up zaz so that both changes are reflected in it. Because it's relatively easy to merge different branches together. So for a little illustration of a simple case of merging branches, this is updating from the server. So you've done your fetch, and now you're doing your merge. So you're taking the new commit from your repository and merging it into your workspace. So currently you have, each branch will have its own name, and the default branch is called master. So your master branch is on commit 2. But somebody else had updated commit 2, changed some file or another, and so you just downloaded that change from the server, which is known to Git as origin. So that's going to be called origin/master, as that is the master branch of origin. So now that you have both those commits, you want them merged together so you have the updated version of the code. So now, workspaces, how they work is they take one commit that a branch is pointing to and have that as the files that you're working on in your directory. So in order to get the updates, you have to merge origin/master in with master. So this will combine the files, like I said. So then you have the files, and once they're merged together, you can then take them as a new commit after you add whatever edits you set out to do. This will create a new commit, and since you were on master to begin with and you merged origin/master in to master, then master is now pointing to the new commit. Whereas formerly it was pointing to commit 2, now it's at commit 4, which is the combination of commits 2 and 3. Origin/master, because you haven't pushed yet, is still pointing at commit 3. As soon as you push it, which is the last command you do, then that'll take origin/master and point it at commit 4, so that when somebody else goes in, they'll be able to merge commit 4 in with whatever commit they have. Like I said, Git will handle most of the merging cases automatically. If you haven't added a new file, Git will throw that in. If you updated a file and the old file was unchanged on someone else's computer, it'll just take the new version of the file. Even if two people edited two different parts of the file, of the same file, Git can automatically figure out that both of those additions should be in one file. We'll merge them automatically. There are only two major cases where Git can't automatically do a merging, and that's binary files. And that's a file that's not saved as text, so that's something like an image, a composition. That's a rarer case, as usually, and it right, you're not going to have two artists working on the same picture. But a more common case is one where two people modified the same method, for example, and made two different versions of the same method. So Git knows that it can't do that automatically, as there are two versions you have to pick from. And so it puts the file in conflict. So when it's in conflict, Git adds some special characters so that you can find it easily in a text editor. This is in the case of a text file. So it'll have less than, etc. And the first commit that is in conflict, it'll have that version up there. So it'll have public static void foo print love, and then equal separation between the two versions, and then under that will be commits two version of the code, public static void foo print hate, and then it ends the sort of commit block with the greater than. So all you need to do is go into your favorite text editor, go in, take out the special characters, and then manually write the method to be whatever you need to do. If it's picking one of them, then you just delete the other one. If you need to merge them together, you can just do that in the text editor. There are GUIs that show merging. I personally find them not super helpful because it's very difficult to actually resolve the merge using those tools and to then indicate to the program that the merge is resolved, and it can remove the special characters. But you may have different luck with that. I'm just telling you they are available. So now you've resolved your conflict. Your file is now ready to go. Git, as soon as it detects a file's in conflict, it takes it out of version control so that you don't accidentally commit the file with the conflict tag still in it. So you have to consciously resolve the conflict. So what you do there is you use the add command, which will take a file that is not version controlled that's in your directory and add it to version control. So all you need to do is, once you're done with the conflict, or if you have two binary files in conflict and you've picked one, just add it back to it, and then it'll be back like nothing happened. So I'll go quickly through a couple other useful commands. These you won't encounter them as often, but you may still run into them. Like I said, add takes a file that's in your repository but hasn't been added as part of the version control and puts that in the version control so that in your next commit, Git knows to include that new file or the file that you just resolved the conflict on. Ignore is the opposite of add. It takes a file that is in the directory and tells Git not to add it in the version control. This is useful for, there are some programs, like for example, David's using Loom for his program, and Loom has one file that is called main.loom, I believe, and it's compiled Loom code, and it changes constantly, but you don't need to synchronize that change. That's something that the compiler does automatically. So that's a good example of a file that you want to take out of version control so that you don't have to constantly deal with the fact that the file's in conflict, because it doesn't matter that it's in conflict. But depending on the project, there will be files like that that you want to leave out, and ignore is the command to get that to work. There's also pull, which is convenient for when you've set up branches that are meant to be the same on everyone's machine. For example, the master branch should presumably be the same for everyone. If you set a branch to track another branch, then it just tells it to synchronize. Like I said earlier, branches don't automatically synchronize. If you track, it can do that automatically. And so once one branch is tracking another, for example, master tracks origin/master, you can then use pull, which just does fetch followed by merge. So you don't have to do both commands separately. You can just say git pull, and it automatically takes the update and sticks it in the repository and then sticks it in your directory. You can configure for branches other than master, which are the ones you're more likely to be working on. Tell Git to track a remote branch with branch menu can track origin/menu. So now a little bit more on branches. You don't have to have branches that are the same on everyone's. You can have a minor branch that's just for you. So you're working on a specific issue, like there's some bug in the program that's going to take you a couple iterations to figure out. in order to sort of save your code to allow you to revert to it if you screw up something else later, you can create a branch that's just on your computer. So you're committing to that branch but not pushing it yet. So then you do that several times, and then once your bug fix is ready, you can then merge it in with another branch that is being tracked remotely and push that up. So this allows different groups to work on different parts of the code on their local machines and then put them together at the end because, like I said, conflicts are a relatively rare occurrence. So an example of a workflow that uses branching to be a little bit better is, since this is student game developers, we'll use a game development example, something that I actually used in my game design class this summer, where we had a game and we wanted a menuing system and a game. But we didn't want to have the code open and show the menu and us have to navigate through the menu to get to the game. So we took one of our team members was working, and then we're on the skip menu branch. So the skip menu branch tells the computer to go straight to the game, whereas the menu branch has it go to the menu so that it could configure the menu and flesh it out properly. So what we've done is we've taken commit 1, and we've just made that one change, saying go to menu, at commit 3, and then commit 2, we have it say go to the game, effectively. So we have two different branches going, and these branches are branches that everyone can see. They've been pushed to the central. Now, the skip menu group makes another commit. So now they're at commit 4, menu's back on commit 3. But now let's say the menu is stable and ready to be put back in the master branch. You can then go on to the master branch, merge menu and master. So then those two come together in commit 5. So now commit 5 has the new version of the menu and is currently telling the game to start by going to the menu. Skip menu, on the other hand, is still telling the game to go to the game. And since they don't need the new version of the menu yet, they don't need to merge it in yet. So then skip menu has moved along with an older version of the code, but the older version of the code is stuff that they don't need yet, and it's easier to just have the game skipping straight to the game. Whereas meanwhile, the menu has been added to the master branch. Now, two things have happened here. The menu is continuing along and being developed a new version that's not quite ready to go to master. And let's say the game, they have a point where the code's got stable and they want to put it in the master branch. They can then merge commit 5 and commit 7 while on master to put the code together. So now the master branch, and there would be a conflict here in the main code where it says go to menu or go to game. So there you would just resolve it to say go to menu, as that's ultimately what you want the code to do. So now the master branch has the updated version of the menu and the updated version of the game, and is telling the program to go to the menu. Skip menu still has the updated version of the game and says to go to the game, and menu has the updated version of the menu and is saying go to menu. So branching workflow, basically your branches will look like this. You have the master branch by default. The master branch is specifically for stable code. Like if you're going to an expo and you want to show off what you got so far, you want to switch to the master branch, compile, and be ready to go. Nothing that's going to be likely to break. So then you can take a couple branches, like I said earlier, the menu branch, the game branch, branches for different areas of the code that can be a little less stable, that are things you're still working on. And then as soon as it gets stable enough to be added to the master branch, you merge it in, but then you keep the branch going so that you can add more code while you try to stabilize it. And And then on a more local level, you can take that, add topic branches to address specific bug fixes. And this has one critical advantage in that, I don't know if you guys have encountered this, but I have a lot where you take your code and you have to sort of take it apart a little bit in order to add a fix, so that if you're working midway through, the code you have isn't quite compilable because you're still trying to do a bug fix. So if you're in the middle of this, you can have this on a separate topic so that, say there's another part of the code that's breaking, but it's more immediate than the bug fix you were working on. Instead of having to sort of re-put your code back together, fix the new bug, and then go back to the old bug, you can just switch from your topic branch to the bigger area branch back to the code that is relatively workable, do the new fix, commit that, and then move back to your old bug fix, and then work on that, and then merge that in with the new bug fix, which most likely would not be in conflict. So this organizes your code a little bit better. All right, so almost done. Just wanted to end with a case for Git Workflow, because this all sounds like a lot of work, I would imagine. You have to do a little more sort of keeping track of what branch you're on, when you should be switching to a new branch. It's a bit of overhead, as all software engineering is. And SGD projects are relatively small. So I'd like to make a quick case for using Git, as I've described here, a little more closely. One of the big things is you can reset your code to a more stable version. If you break your code, you can reset to a more stable version. If you need to start your fix from a more stable version, and there's a branch available to do so, you can switch it really quickly. It also allows, on a team level, to have your code always have a stable version of your code ready, so that so that you don't ever run into a point where you have to do some work just so that your code recompiles. So if the mid-semester expo is the next day, and you're just throwing commits in left, right, and center, you don't have to sort through them all to find the ones that work and then put it together, because you can put the new code you're adding into a branch and be testing them carefully, and only merge the branches that are stable in with your master, so that you have it organized and ready to go. So when the mid-semester expo rolls around, even if some of your code didn't quite make it, you don't have to sort of sort through your code and look for the methods that don't work, because you only add them in to the master branch, the one you'll be showing off when you've completed it and it's stable. There's also, as I explained earlier, you can use different versions of the same class to make your workflow a little easier. For example, the main class that tells your program to skip the menu and go straight to the game, which when you're testing over and over, even a one-click menu can be kind of annoying to deal with. And this allows you to I think that the more you know about Git, the more you get over the initial sort of confusion around it, the better off you are. All right, we reached the end of my talk. This is far from a comprehensive guide to Git. If you want one of those, you check out ProGit, which is available at git.scm.com/book. My talk borrowed quite a bit from that book. It's available under the Creative Commons license, so you don't have to pay for it. That being said, any questions?